Okay. In the previous class, we have seen what is probability in this. And today's class, we will see what is discrete probability distribution. Just I will tell what is what, and I'll directly go into the next part. See, here, if you take the previous units, it talks about the central tendency, variation, Q-ness, correlation, regression. Right? That is what we started. Central tendency is about the mean, right? We have seen till now. And then, yes, sir, is my voice audio?
Yes, sir.
Is it clear? Yeah.
Sir, your name is Swarup Rai, no, sir?
Correct, sir. 1 second. I'll rename it. Sorry.
Okay.
Sorry. I just, another account is logged in our college. Yeah. Okay. Right, sir.
Okay.
Yeah. This is the till now, if you observe, we have seen what is mean in that. We discussed about the central tendency. After that, we have seen the variation of that. In that variation, we learned about standard deviation and other things. And after that, we learned about the skewness or the correlation and the regressions. See, all those things are where the frequencies, the numbers that we have taken are by the experimentation only. And these free distributions are formed by the collection, maybe classification and tabulation of the data. For example, here we say drawing wages between this to this, how many between this to this, and so on. The marks obtained by the students from this to this, and how many are more than this, less than this. And actually, we have this. They're also called as the observed or empirical or actually frequency distribution. Now, as against above, we can derive expected frequencies on the basis of some mathematical relationship, right? The frequencies. Frequency means how many times it is occur or how many times it will. Now, that is the probability of getting a head is half, 0.5 frequency. Suppose if we toss the coin 50 times, every time the head or tail is noted. The number of times the head appeared is 29 times. This is called actual or observed frequency. Okay. Now, but out of 50 times, how many times we can expect head? We can't tell it, right? This is called expected or theoretically expected frequency. See, this is observed or actual frequency that after doing that, what is happened that we have seen that is actual or observed frequency. And but expect head, the probability, how much time it can say. If I throw a coin or if I toss a coin, how many times it will come? That is called the expected or theoretically expected frequency. It is based on probability. We know that. Hence, it is also called a probability distribution. Remember that. Okay. And hence, we can define theoretical or probability distribution as those distributions which are not obtained by actual observation or experiment. See, previously, whatever the things we have did, like your mean or skewness or regression or correlation, whatever the things that we have discussed till now, already those are all the actual values, or in other words, observed frequencies or observed values. Now here in the when we don't have the actual things, we need to go by the expected things. How many I can expect if I toss a coin? Maybe 50 times only head may come. Only one time head may come. That is expected, right? That's frequency. And that we call it as a probability distribution. Now, how we will define that? The probability distribution are those distributions which are not obtained by actual observation but are mathematically deduced on certain assumptions. Okay. And these distributions are two types. One is actual frequent distributions, which are based on actual data, probability distribution, which are based on expected values. Okay. We know that what are random variables and probability distribution is like this. So distribution of probability outcome that could result is performed. In other words, a table listing of all possibility values that a random variable can assume together with their probabilities is called the probability mass function. If a die is thrown, the random variable is X. Number of on its face is then like this, 1 by 6, 1 by 6, a die. Okay, if it's a die, 6 faces will be there. And see, the assignments you need to solve on your own. No? We are not supposed to, help you in that. That is the instruction we received from that. Okay, that you need to solve. Someone send me a text message. What's this? Okay. Right. Then another example, if the two coins are tossed, the probability of getting head, one head, two heads are as follows. This is the things. 0, no head, only one's head, two-side heads. Okay, this is the thing. Expected value of a random variable. The expected value, that is mean, the random variable is defined as the sum of the products of the random variable with their corresponding probabilities. See, this is the thing. This is expected value or random value. We will take the expected value and we'll multiply with the corresponding probability. We need to take the corresponding probability. And then if you multiply, see, x1, p1, x2, p2, and so on. This is the expected sum of probability, sum of p of s is equal to 1. It can be written as sum of xy. This is the mean and the probability. You need to multiply this into this, then you will get the expected value. Okay. First thing, types of probability distribution. One is binomial distribution. Let's try to understand what is this. Binomial distribution known as binomial. It is widely used probability distribution. It is concerned with the discrete random variable. Hence, it is a discrete distribution. Okay. For example, associated with the name of Swiss mathematician, this one, it is called this man Bernoulli. Called in this year they have given this. That is why they are also called as the Bernoulli distribution, because the name is included in that sort of thing. And now in this distribution, expressing the probability of none of the set of decauses, two alternative success P and failure Q. For example, if a coin is tossed, there are two alternatives or possibilities, a head or a tail. We know that. The tossing of fair coins some fixed number of times is a Bernoulli process. Coin some fixed number of times. And the outcomes of such tosses can be represented by the BD, binomial distribution. Again, I'm repeating, this word is important. If you understand, if you didn't understand, that's the thing. There are two alternatives. We know that a head or a tail. If I toss a coin, head or tail, two alternatives. The tossing of a fair coin some fixed number of times. Once I toss, second time, third time, fourth time, fifth time. How many times I toss, that is called the Bernoulli's process. And the outcomes of such choices can be represented by the binomial distribution, the outcomes. Okay, now the concept of BB, suppose success is the probability of an event happens in a single trial. Q is the probability that event will fail to occur. Okay. Then the probability of that event to occur exactly R times in n binomial trials is given by P of R. This is R times and NCR into PR into Q power n minus R. You need to by heart this formula. This is called the binomial distribution. This shows the probability function of the binomial distribution process. Okay. Parameters of binomial distributions. This is the R is the event. Number of success desired like 0, 1, 2, 3, small r. That's what we said. How many times? Probability of success in a single trail is the P. For example, if I tossing a train, the coin, the success. For head, I am just tossing. This is the thing. Probability of failure in a single trail is 1 minus P. And and probability of failure in a single trial is 1 minus P. N is equal to number of trials. Okay. This is the thing. See, number of trials is a binomial process. The outcome, the positive outcome is called the binomial distribution. Based on those things, this formula is created. Okay, this formula is the created. General form of BD depends on the values of P and N. The useful generalization are the P value is smaller than say 0.1. The BD is skewed to the right. We have seen the skewed, right? Positive skewness and the negative skewness, right side. If it is less than P, then BD is positively skewed. When P value is more than 0.5, the BD is skewed to the left. When P value is 0.5, Q is also, then BD is symmetrical, bell shape. Like this, it will come. Symmetrical means it's not neither that or this exactly at the point that is symmetrical. The point will be there. See, if it is going away right to the right, value is small, say 0.1 is to the right. There's more than 0.5, the skew to the left, like that. More than 0.4, left 0.4, 0.3, 0.2, like this it will go. Right, it will go further for that. And the P value is 0.5 and Q is also the Q is also this. The greater the divergence between Q and for a given N, more pronounced word to be school. The mean and standard deviation of BD. The expected value of random variation is mean of the random variables of the binomial is equal to N into P. And the variance is equal to NPQ. Hence, the standard deviation of BD is square root of. See, the square root of variance is equal to standard deviation. The variance is NPQ. And the standard deviation of BV is equal to this formula. Okay. And the characteristics, you can go through that. And procedure for solving a binomial problem. Let's see one formula here. Yeah. Now, see this. 5 coins are tossed 320 times, and the number of heads appearing each time is recorded, and tabulated results are presented. Okay, number of heads 0 times is 8 times when they tossed. 8 times they didn't get the answer. 51 times number of heads 1 is 57 times. 2 times 1 turn, 3, 4, 5, 6. For the probability of obtaining 0, 1, 2, 3, 4, 5 heads, also find the expected frequencies per BD. See, for 1 time 57 probability, observed frequency 10. See, when they toss the coin 320 times, the number of head appearing each time is recorded and the tabulated results are also present here. This is the time. Okay. Now, what is the formula for this probability distribution? NCR, Q power N minus R, P for R. See, this is the formula. You need to keep this formula in your mind. Okay. Now, how they have solved this? Let's, where is this? Yeah. Here N is equal to 5. Capital N is equal to 320. You know, this is 1, 2, 3, 4, 5. When the coin is tossed, the probability of getting head is P 0.5. You know that because how we got 0.5? Hello? How we got 0.5?
Yes, sir. When the toss is when the coin is tossed, it's having
head.
a toss.
The expected is 1. I mean 1 head. And how many possibilities are there? Head or tail? 1 by 2.
Yes, sir.
Right. 1 by 2 is equal to 0.5. Same for the tail also. 1 by 2, 0.5. The various probabilities for all the events terms expansion is Q plus P power N. For N coins, N is equal to 5. There will be 6 terms, one of each are R, 0. These are the numbers. Apply Q plus P power N, NCR is equal to this for each term. Now the explanation will be, see, Q plus P power N is equal to NCR, NCR, Q and the plus, this one. See, this is what? First you will apply 0 in the place of R, you next 1, next 2, next 3, next 4, 5. Like that you apply here and you will get some. The next step is obtain coefficient of the various terms, that is NCR. For this, follow any of the methods explained already. The obtained coefficients are 0.15, 10, 10, 10, 5, 5. Now the expansion is like 1 into point q p power 5 into q power 0, p power 4 into p power 0. Like that you will find. Now probabilities of R event are this one, NCR. Now 0, okay, and we got this value 100 or 1 by 32. And this is the PR, we got this value here. And the expected frequencies, of course, we know 320 is the frequencies. And at the 0 height, we got 10, 50, 100, 100, 150, 20. The total is 320. To get the expected frequency, multiply the probability PR by the number of trials N, this one. Capital N is 320. Now the observed fitted distributions are as follows. Observed frequencies are 857. That is what they have given. Expected frequencies, we have multiplied this into this. We got this value. The theoretical values of mean, variance, standard deviation of fitted expected BDR as follows. Mean is equal to NP, 5 into 0.5. Variance NPQ, this is the thing. Standard deviation, this is the 1.125. See, this you got already. Observed, they already given. Expected frequencies you should get by using this formula. Once you keep the table here, once you get these values, and you can easily you can get this mean variation and the standard deviation. Okay. Now let's go into the another model, Poisson distribution. Poisson distribution is used very widely, always social science. It is used to study the probabilities of rare events or infrequently occurring events. Binomial distribution is an expected things. See, we can't tell, rarely only head will come. Rarely only the toss will come, right? But here, incidents like earthquakes, wars, production of defective items. In physics, the emission of radioactive substance, rare event. Okay, the rare or improbable events, hence it is called the law or distribution of the rare events. Okay, law of improbable events. Those are all the probable events. These are the improbable events. Now let's see the definition. If non-negative M is the average value of the variate relating to an event, which happens repeatedly, but randomly at a point of time or an interval of time or in region. The distribution of R given by the law is e power minus m power R by R factorial is called the Poisson distribution. You need to by heart this Poisson distribution. P of R is probability of success of R event. How many events are there? That is R. R is the number of occurrences. E is equal to, based on natural logarithms, you need to take this value from the table. M is equal to a constant, a parameter of the distribution. M is the average number of the occurrences. Okay, these conditions you can see. Let's go and see. We'll see some because we need to go for the next part. That's why I'm hurrying up. Sample of 100 pages were taken from textbook and the number of printing mistakes per page was found as to below. See, number of mistakes per page. No mistakes, 48. One mistake, 27. This is like this. Calculate the theoretical expected frequencies using Poisson distribution and also find the mean and variance of the fitted distribution. See, frequency is this, f of x is this, we find out. And the m, what is m here? Sigma f of x by small n. Sigma f of x is n, small n is equal to 100, x bar is equal to 1. Observed frequency and n is equal to sum of f. M is equal to x bar is equal to 1. That we got it. M value we got it. See, we want to apply this formula in this. E power minus m into this. Where is the formula? Here. This one. You keep this point in your mind. M you want, you want, R already they will give that. Okay. Now x bar is equal to 1. We got it by using this formula. Small m we got. A law of probability R is equal to this. Mistakes are given by P of R and the frequency contains R mistakes are given by capital N into P of R. Let probability of 0 mistakes. P of 0 is given by, you put the 0 here. E already the standard value minus 1, M 1, 1. You'll get it. E power minus m is equal to this one from the statistical table, 0 point this one. You need to take from the table. Okay. E is equal to this one, m is equal to 1, R is equal to these numbers. m power 0 is equal to 1. Computing by taking reciprocal, we will get this, and therefore P naught is equal to this one. See, finally, we applied the formula P naught and we got this value. Now, the required probabilities and occurrence frequencies are follows. Now, P naught, we want this one, m of r by r factorial. We need to calculate this here like this. Apply the formula in that. You'll get this value. You'll get this value. And n P of r. N into capital P of R, you will get this value. And expected value is number of pages is this. See, these are the things they have given. Round of the number of pages. These are the, see, we are taking the expected probabilities, right? Yeah, number of pages is this, the probability we got. And the problem distribution mean and variance are equal. Already we calculated on the top. And therefore, the main is of the fitted distribution is 1. The slight difference is due to the approximations. See, if you understand the formula, understand the value where you need to think, and you know how to see the table values as well. Okay, you type Poisson distribution table in the Google, you will get it if it is not there in the textbook. Okay, now I want to go to the last thing. This one, normal distribution, we may not get yeah, okay, just I will see what is normal distribution means. One of the most important widely probability models is the statistical analysis. This is also unlike, it is not like the BD or PD. This is normal probability distribution because relative frequency of the continuous random variable are distributed according to the normal probability. It is a balanced symmetrical distribution, neither not right side or left side, so that symmetrical distribution are distributed evenly at the same line. To one go far away left or far to the right. The normal distribution also called as normal law of errors was first discovered by an English mathematician, Abraham D, as a limiting case of this model. This is also called as Gauss distribution. Now, and is a variable when represented graphically takes the shape of a bell. This is the thing. Okay. And this is denoted by mu. And the random variable x follows ND with a mean of mu and the standard deviation. If you draw the graph of an ND, the curve of a normal curve looks like this. The importance, just you can see the properties of the distribution. Yeah, percentage distribution under the normal curve. Applications of the distribution, central limit theorem, conditions of normality. Where are the sums? Yes. A standard normal distribution, Z transformation is capital X minus mu by alpha. And finding the area under the standard normal curve, we need to find out the area that we have seen in the previous image. Now let's see this. Let us assume a distribution with the population mean of 100 units and population standard deviation of 10 units. That is, mu is equal to 100, sigma is equal to 10. See, this is standard deviation of 10 units. And then what is the area between 90 and 110? Okay, 90 and 110. Mu is equal to this. X1 is equal to 90. X2 is equal to 110. Let's convert X1 into Z variate. X scale. Z is equal to, this X bar minus mu by minus 1. Similarly, convert X2. X2 minus this. Minus 1 to plus 1. It is there. Minus 1 plus 1. It means that 90 and 110 are at a distance of 1, right? And from the mean ordinate, now we have to find the area between 90 and 100. That is minus 1 to 0, minus 1 to 0, 90 and 100. So 100 is the point, middle point. This we called as a mu. Already we got it. 100. That is what we need to find out there. What is the asking? 90 and 110 they're asking. If you want to get this 90 and 110 minus 1 to 1, first get this information 90 to 100. Now, and between 100 and 120, that is 0 to plus 1. This one 0 to plus 1. Here 90 to 100 are scale limits, 0, 1 and the Z limits. Now the area between the 90 and minus 1 is equal to 0.34134. Calculate this, you will get it. And the area between this one, 100 to 110 is equal to 0.34143. Then the complete thing, the area which is covering between this to this 90 to 100 is 68.27%. And what we mean by mu plus than is covers the 62% of the area's frequency. From here to here, this is total thing. And we got the middle value as this, and 90 to 0 to 0.34. We can see the normal distribution table. Then only you will get these values. And from this will come. That means what? Almost 90 to 100, 68%, they are covering the area in the normal distribution, the curve. Okay. The same with this. See, if you understand this formula, if you by heart the formula, where is the formula? Yeah. Z is equal to this one. And in order to find the Z, you can't directly put Z there because you need to get the variance of this first Z. X1 minus mu by lambda, X2 minus this one, this. We have the X1 as 90, X2 as 110. Already they have given. We are calculating in between value 90 and 100. That is why 2x variates we need to take. For the variates, x1 minus mu by sigma. Okay. That we just go through the, then you will understand the other things. Now we are going into the another part. Till now what we have discussed is a different thing, but this is a different thing. See, these are all till now what we have discussed all to calculate the things by using these tools. Now here, I will just go through important parts here because we have 4 units and we have this very less time. We already learned what is sample, the mean and characteristic. This is a theoretical part. Different types of sample design, and this one is the 5th unit. After taking the sample design, we need to test the hypothesis. We will see what is hypothesis means and types and characteristics of the hypothesis. Now, tests of hypothesis explain the meaning of parametric and non-parametric test along with its application. Thus, those tests we need to understand. And interpretation of the data and the data reporting is an easy thing. After you getting the results, once you get the values, some values there, and those values now, how you'll write it. Say already we are converting the theoretical part into the numbers, and we are using different analytical tools on the numbers. You will get also the result in terms of numbers, maybe the percentage or points of this. How you will interpret the data. This is also very important by looking at the values in this. You need to do that. Okay. A lot of theoretical part is there. See, in a simple words, I'm telling what is sample means. For example, if you are cooking a rice, okay, to check whether the rice is cooked properly or not, what you will check? How many grains you will take? Check whether it is cooked or not.
Yes,
or
sir.
else today, huh?
3 or 4.
3 or 4. Today is Sunday, right? Many of you are preparing some non-veg or something, right? How many pieces you will eat to check whether it is cooked properly or not? You won't eat the whole chicken, right? If it is chicken or mutton. One or 2 pieces, and the right piece is also very important. There are small pieces which will boil quickly. If it is big pieces, or again, based on the thing, what we need to take is an important thing. That is the sample. See, when you want to understand the concepts and this sample design, fairly good results are often better than those obtained by the census method. Selection of representative sample from clearly defined universe aids to explain data collection are to this. You can go through this. Features of good sample, reliable and valid sample. Representative should be there. See, this is the thing. If I'm taking a sample size from your class, see, both the male and female are not same. Again, I need to consider how many male, how many female. In that, you need to take, okay, if I take 2 people to understand whether they are happy with the classes or not, that's it. And in the two people may not tell the all opinions of the girls. That is why representative, whether that sample size is representing the whole or not, we need to understand. Randoms. Each and every element in the universe should have an equal chance of being selected. Okay. Economical. Achieve optimal results with minimum cost, practical, and information provided. Advantages, less cost, less time. Types of sampling. There is again probabilistic sampling, also known as random sampling, taking here and there. Non-probabilistic sample, that is called non-random sampling. In the random sampling probability, each element in the universe being selected is equal, but such is not in case of the later. The danger of unknown sampling bias can be minimized due to the randomization. An important difference between random and non-random is that the pattern of sampling variability can be ascertained in the former and no way of knowing the pattern of variability in the later. Okay, let's see this. Probabilistic sample. Simple random sampling, restricted random sampling. Okay, in the restricted random, stratified random, cluster sampling, systematic random. Non-probabilistic sampling, quota sampling, judgmental sampling, convenient sampling, self-selected sampling. Next one, multi-stage and multi-stage sampling. Let's see what is what. Simple random follows a simple procedure of drawing sample from a universe with an equal and independent chance of being selected. If I take from the universe from a universe means not from the whole universe, from the selected things and from the required people. That is from class I am checking. The whole class numbers is called the universe here in our example. And drawing a sample with equal and independent chance of being selected. The selection process of sample is random in character, but usually representative of universe and reasonably accurate data. There are two basic procedures for adoption of simple random. First, the lottery method, most familiar procedure. In the selection of set, 5 out of 50 students universe, take 5 equal size slips of paper and them onto 50. Mix the slips and you will get 5 slips completed. Such procedure would yield a simple. Second, the use of table of random numbers is an idea of selecting a random sample from the universe related to the small dividing anyway. To select 25 out of MBA from the Department of Universe, use any table random numbers, take the telephone directory and open it any page and use telephone numbers to draw the sample. The telephone numbers are 5 digits and n is 250. Use only 3 digits either from right or left of a page. But see, these are different methods they are telling us to take, how we need to take. The following is the table of random numbers of 30 consisting of 4 digits. How should you use this table to make a random selection of 10 out of 250 without replacement? How we will take? Yes, ma'am? Generally, if you want to take, how you will take? Simple. The numbers from 1 to 250 start with first number in the table, picking out, moving right side 3 digits from right side of the figure less than or equal to 250 till 10 units are updated. The process, the digits number which are over 250 are ignored and take only once if the numbers are repeated in 250. Simple. Stratified random samples. Simple random sampling, all the features may not get a chance to represent. In that case, a randomness is restricted. See, when I am taking a sample, I cannot represent, if I am taking a sample, that sample may not represent a particular group. As I tell, male and female, the problems of anything, right? Anything when you are taking, when you are taken only from the male and you are not representing female there. Well, that there is no chance of that. And then this won't be work out. Improved type of random under which the universe is divided into groups, subgroups, strata. Like for example, age, sex, and etc. etc. Now, this is the thing. Sample size 10%, hence 180 persons would be selected in the sample. There are 9 stratums and follow appropriate stratified sampling. Okay. Selection of teachers with length of services less than 5 years, 900 into 3 by 6. Based on the table, they have calculated. You see this. Systematic random sampling, this we called as a pseudo-random sampling. Selection of every kth unit of the universe is fixed at interval with random kth material. It may be 10th one, 11th one, or 5th one. You will fix it. Then first unit is the random within the sample. And the basis to remaining units is automatically selection in the predetermined way based on the equidistance like students in a class. Houses in a street, bank accounts, or a town, a factory output, whatever. But you will go for systematically 10th one, 15th one, whatever you want. See, there are select a sample of size 12 from a list of 120 students. How you will get? Divide the population into 12 by 10. Then 10 is the resulting quotient. Take integer only, ignoring fraction if any. For a selection of random number 1 to 10, use the lottery method or table of random numbers. Take from 1 to 10, 1 to 10, 1 to 10 because you got 12, the 10, and then select the kth item based on any criteria. You can take it. Multi-stage sampling and multi-phase sampling is like in the, not in one go, you will take in this. For example, you are working. After 1 hour, what is the result? It takes few samples. After 2 hours, what is the results? After 3 hours, what is the results? Okay, that is called multi-stage sampling or multi-phase, different place. Now, non-probabilistic sampling is quota sampling. Quota sampling, the universe is divided into categories. Within a category until the needed sample size is obtained from the interviewer should be instructed to collect information from the assigned unit COSA. For example, like sex, age, income, as per the sample selection is a replica of the population. One would wish to generalize and effort those of diverse elements inclusion in the population. For the market surveys, opinion polls, the relationship survey, which generally do not aim at a precision, but to get some crude results as quickly as possible, less cost and less thing will be added. Now, how to design a sample? What is the concept and purpose of inquiry? Sample design is to collect data. It is always desirable to decide the sample size and technique of sampling. Size, you need to decide, technique of sampling. Therefore, the sample design is an important part of research design, which plays a significant role in that. Now, relevant population. The criteria set above are conflicting. The researcher must blend them to get a good sample design. Relevant population, survey of pertinent population depends upon the research problem. Study objectives, geographical area and the operation definition of the unit. Funds fraud in banking system, manager satisfaction in public enterprise, and the study of consumer behavior related to the toilet soap. The relevant population is the managers at various level of public organization, household in area of survey. So examples respectively. This is the relevant population, which are relevant. Sampling frame. This we need to do. List of population which are sample is collected as a sample. We know that how many we have taken from the universe which is sample, and should be a complete and correct list of elements only. The available sampling frame not only meet requirements of sample because of the shortcomings. These shortcomings are these things: sample technique, sample size, characteristics of good sample design, sample design and its determinants. You need to calculate in that. Sampling distribution. Okay. These are the basic things. Now, remember hypothesis. This is also important part. Let's see this as well. What is meaning of hypothesis? The scientific examination of a problem to know the truth with the reasons thereof is the purpose of research. We know that, right? To know the truth or to know the solution for a problem or to understand what is the things, is called this. That depends upon the statistical survey with the aim of drawing the factual and inferential logical conclusion about the problem. The decision based on the analysis of observation is this. Research designs with a problem, finding solution to the aim of the research. The formulation is the tentative solutions as propositions and examined diligently the research product with you verifying the truth is called hypothesis. This is important. Say, I'm telling there will be a success. That is my hypothesis. There will be a variation between that. And one variable is increasing, another variable is going down. There is an effect of social media in the lives of the students. I'm making a lot of things. I want to know whether there is an effect of social media on the student studies, how I should frame my hypothesis. You need to go in this way. There is a relationship between social media influence and the studies. What is the reverse to that particular statement? There won't be any relationship between the social media addiction and the studies. Hypothesis is like that. See, this is a tentative decision, may or may not be the real solution. No observation is worth sharing without having a hypothesis or a test to establish this. What is merely derived from the hypo and thesis, which literally means under or below for the reason, theory of rational viewpoint, respective. Elimination of unnecessary of irrelevant facts. And consideration of those relevant facts certainly needs the formulation of hypothesis. Definitely. To remove few things, we require this. Diligent investigation also begins with the research problem. Okay. There is no real solution to the stated problem. It is a universal fact. And the purpose of research is to solve the problem issues found telling the course of investigation, the process. Read this. I did not take hypothesis, but fully recognized the importance of hypothesis for scientific theory. And Huxley, every great step in science has been possible by the invention of hypothesis. Hypothesis is an assumption. Verifiable, often very little to start with. The following are some definitions of hypothesis. Is the proportion which can be put to test to determine the validity. Testing. It's a generalization, the validity of which remains to be tested. It is an island in the uncharted sea of thoughts to be used as base for consolidation reputation. What are the types of hypothesis? Exploratory hypothesis, descriptive hypothesis, working hypothesis, null and alternative hypothesis. Characteristics: conceptually clear, empirically testable, specific. You can read these things. Procedure. How to start with the procedure. This is also important part. Statement of problem is foundation upon which a diligent research or investigation begins. Formulation of hypothesis about population parameter is the first step in testing of hypothesis. When any person is framing a hypothesis, then we will do. Formulation of hypothesis about population parameter is the first step. And see this mark, very important. It must be considered in such a that if null hypothesis H0 is accepted, the alternative H1 is rejected and vice versa. These are the words they will use generally. What? Null hypothesis or alternative hypothesis. Null hypothesis, generally they will represent as H0. And what type of, the material you are getting to use it, whatever. The alternative thing will be the vice versa. For anything it will be. This is important word again. Null hypothesis talks about there is no difference between sample and the population. And the differentiation if found is accidental and unimportant, arising out of fluctuations. You got it? There is no difference between sample and the population. No, it's not working out. Then hypothesis will be rejected. Null hypothesis asserts there is no true difference between the sample and the population and the difference of any. Right. Next. This is also important part. See this. Null hypothesis. The population mean is equal to 150. Mu is equal to 150. H naught. What is alternative hypothesis? The population, see, let me read this. Where is this? Suppose the mean population is equal to the null formulation are given below. The mean is 150. We don't know how many they have taken, but mean is 150. If mu 150, H naught, if we got null hypothesis, the population mean is equal to 150. Alternative, it is not 150. If it is not is equal to, the population mean is not equal to 150. Or if it is greater than 150, if it is less than 150, okay, H1. Null hypothesis will be 0. Alternative hypothesis is based on these values. Remember that. Another important aspect in the significance, hypothesis is that level of significance. The validity of null hypothesis or alternative hypothesis is tested at certain level of significance. Acceptance or rejection of null hypothesis depends upon the adoption of the significant. Customarily, the significant level is expected at the present of 5 or 1, which are accurate. Where it is, which are significant level. Customarily, the significant level is 5% of 5 or 1, which are accounted for moderate precision, high precision. Therefore, the decision rule is this. The HR juice is rejected at the level of significance. All the time, maybe the level, maybe they will give in the question generally. See this? Let's see this. Given below shows the interpretation of significance level 0.5. In each tile is 0.25. Area under the normal curve. 95% of the area covered by an interval extending 1.96 in between two regions. 95% area covered by an interval extending here. When it is tested, yeah. Significance 0.5. For tile, it is 0.025. Under normal curve, 95% of the area covered by 1.96 in between two regions. It is also illustrate regions accepting or rejecting null hypothesis. So this is 0.5 here, 0.25, 0.25. Shaded region where there is no significant difference between the sample statistical and hypothesis population merit. This is an acceptable region. See this? If it is, this is the level of significance. If it is going beyond this is the right side. We can't accept this. Okay, critical region also, there is a region. Test statistics, there are different tests in that, Z test, C test, P test. And types of erroring, when the type 1 error, when there is a true is called type 1 error. When it is true is called type 1 error. When it is false, it is called type 2 error. And type 2 error and any statistical 4 possible decisions are there. This is the thing. You can go through the table. There are different types, one-tail test and two-tail test. This is the thing, one-tail test and two-tail test. Statistical estimation, point and interval estimation is there. Just this is the theoretical part. You can go to it. Okay, there are tests also there. You can just check what is this. You will understand that based on the sample size, different tests are used. What is Z test? What is T test? What is chi-square test? There are three tests. If you just go through the problems here, you will understand. Yeah, see this? Point interval, hypothesis testing, Z test, small or large use of Z test. Okay. And A.R. Fisher developed this. And where is this? Yeah, this is the formula. Sigma is equal to root of NPQ. Okay. Estimating the number of success based on, see the formula, introduce, substitute in that formula, you will get the value. Okay. Okay, with this, I will stop here. And maybe what my suggestion is that you need to go through the notes, and after going through the notes, you try to solve the formulas. I mean, by heart, write every formula in one paper for each and every topic. Take some examples, substitute that in that, and you'll get the answer. Okay, we don't have time to go to more examples and this. With this, I'll stop here. Okay, ma'am. Everyone, bye. Have a nice day.
Okay, sir. Thank you, sir.
Yeah.